Today, a Chinese rocket was launched into orbit, taking 3 astronauts to China's space station. It's named Tiangong, which translates to Heavenly Palace.
China has successfully launched 3 astronauts into space as it strengthens its ambitious space program.
From our spot here at the Zhoushan Space Center in the Gobi Desert, we just watched China's latest entry into space, a rocket carrying 3 astronauts to China's space station. Take a look at the launch.
The Chinese space station is a marvel of innovation in space exploration. It's a giant floating lab, carefully crafted with incredible technology. How did they build it? What experiments are they doing up there? Let's check it out. But first things first, let's talk nomenclature. Forget the mundane because China has elevated the space game with names straight out of a mythical saga. Long gone are the days of boring labels. Now we've got Divine Arrow, Divine Vessel, Divine Dragon, Divine Light, and Divine Might leading the charge. And let's not forget the poetic touch in naming lunar probes after the moon goddess Chang'e. Talk about setting the cosmic stage. Enter Tiangong, which translates to Heavenly Palace. The launch of Tiangong-1 wasn't just a space event, it was a nationwide inspiration, sparking love poetry across China. Now let's get down to the nitty-gritty of the Tiangong space station itself. Nestled between 340 and 450 kilometers above the Earth's surface, this marvel is China's first long-term space station. It's not trying to outshine the International Space Station in size, but hey, quality over quantity, right? With a pressurized volume of 340 cubic meters, it's like having a cozy space home in the cosmic neighborhood, just over a third the size of its international counterpart. But what makes the Tiangong space station a true marvel? Well, for starters, it's part of the Tiangong program, the core of China's third step in the manned space program. This isn't just a station, it's a strategic move in the celestial chess game. And guess what? Tiangong is set to be the launching pad for the next-gen orbit vehicles, opening doors for scientific and practical applications on a grand scale. But that's not all. CMSA is all about inviting the private sector to the space fiesta, hoping their involvement will bring cost-effective aerospace innovations. Oh, did I mention that they're considering space tourism too? That's right, folks. You might just get your ticket to ride among the stars. The Tianlian-2 satellites provide real-time communication, linking the space station with live audio and video. 3 satellites make up a group orbiting the Earth, offering support and data services to the station. For docking, Tiangong uses the Chinese docking mechanism, similar to the one used in previous Chinese space missions and Shenzhou spacecraft. This mechanism is based on the Russian APAS-89, APAS-95 system. While NASA sees similarities between the Chinese and Russian systems, there are debates about how compatible the Chinese system is with current and future docking mechanisms on the ISS, which also uses APAS as their base. The docking mechanism consists of an 800mm diameter circular transfer passage. There are 2 variants, an androgynous one weighing 310 kilograms and a non-androgynous one weighing 200 kilograms. This mechanism was first used on the Shenzhou 8 and Tiangong-1 and is planned for use in the upcoming Chinese space stations and CMSA cargo resupply vehicles. The space station's power comes from solar arrays on each module. These use special cells to turn sunlight into electricity, which is stored for when the station goes into Earth's shadow. Spaceships bring fuel to power the engines that keep the station in the right place and counter the pull of Earth's atmosphere. These solar arrays are built to work for about 15 years. For moving and staying in the right orbit, the station has different types of engines. It uses regular chemical engines and ion thrusters. Some ion thrusters, called Hall-effect thrusters, are on the main Tianhe module. Scientists in China are careful about these thrusters because they want to make them better without drawing too much attention. They made special shields to protect the thrusters from damage by using a magnetic field and ceramic shields. Tests show these thrusters ran for a long time without any problems, which is good for the station's planned 15-year life. These are the first Hall thrusters used on a mission with humans. There are 5 robotic arms on the station. The longest one is 10 meters and looks like the Canadian SSRMS arm on the ISS. It's called Chinarm and is on the Tianhe module. Another smaller arm, 5 meters long and 5 times more accurate in positioning, is on the Wenqian model. This arm helps with experiments outside the station when astronauts go for spacewalks. It can also connect to Chinarm to extend its reach and carry more weight. The Mengqian module has a different kind of arm. It has a release mechanism to move cargo around. This arm can get experiments from a special airlock and put them outside the station on adapters. It can even launch small satellites. Finally, there are 2 more arms made by the Shanghai Academy of Spaceflight Technology. They are on top of docking ports for 2 laboratory modules. These arms help move the labs around during construction. The Tiangong space station began construction in 2021 with a core module launched first, followed by lab modules. It's the second space station using automatic assembly, like Russia's Mir and ISS's Russian segment. China's tech comes from their space experience and tech purchases from Russia. Training for docking began around 2009. By 2022, 3 22 metric ton modules formed a T-shape for the station. It started with 11 missions, including module launches, crewed trips, and cargo flights. Crewed missions verified tech and did spacewalks, installing gear and testing systems. They undocked, did maneuvers, landed, and practiced various operations. The final construction phase started with Shenzhou 14 overseeing lab module arrivals in 2022. They installed and tested equipment and relocated modules. The last module, Mengqian, completed assembly in 2022. With this, the Tiangong station was officially done. Crew rotations began, expanding capacity for 6 people. In late 2022, Shenzhou 15 crew verified operations for a 6-person team. The plan is to expand to 6 modules and enhance tech for a long operational life, possibly launching a space telescope module in 2024. China faced limitations in joining the International Space Station due to U.S. restrictions in 2011. Instead, it formed partnerships for its space station. Italy, France, Sweden, and Russia collaborated on experiments. ESA initially trained astronauts for China's station but withdrew due to politics and funding. The UN and China chose experiments for the station in 2019, with international teams studying gamma rays, cancer growth in space, and cosmic rays. Multiple countries are involved, planning experiments involving 23 institutions and 17 nations. China's space agency expressed support for foreign astronauts to join future missions, hinting at collaborative work after the station's completion. In 2022, Hong Kong and Macau were included in the station's astronaut selection process. The Tiangong space station operates on China Standard Time. The crew starts their day around 0700 CST, briefing mission control in Beijing at 0800 CST, working until 2100 CST and reporting progress. They take a nap around 1330 CST and have breaks for meals and rest. To mimic Earth's lighting, the station uses a lighting system, managing the crew's body clocks amid 16 daily sunrises and sunsets. The station has smart functions, like remote-controlled appliances and a QR-coded item organization system. Wi-Fi connects devices wirelessly. Meals on board include 120 food types, often solid and boneless. Special sauces help with taste changes in space. They have a kitchen table, a fridge, a water dispenser, and the first-ever space microwave. Following astronaut feedback, more vegetables were added to the menu. The living quarters in the core module have sleeping berths, a toilet, a shower, and a gym. Each berth has amenities and a small window. The station also has provisions for preventing muscle atrophy, with controlled noise levels and ventilation in different areas. The station typically houses a crew of 3 but can support up to 6. Operations are managed from Beijing with an emergency rescue mission always on standby. Crewed missions like the Shenzhou 12 lasting 90 days and Shenzhou 13 for 180 days operate on the station. CMSA plans a new reusable spacecraft larger than Shenzhou for lunar exploration and carrying more crew members. For cargo resupply, Tianzhou spacecraft, a modified version of Tiangong-1, autonomously delivers supplies, offering a cost-effective and reliable approach for routine operations. Comparing the American International Space Station ISS with the Chinese Tiangong Space Station involves various factors. While the ISS boasts larger dimensions and international collaboration involving multiple space agencies, the Tiangong station showcases advanced automation, smart features, and newer technology. The Tiangong station's design prioritizes efficiency, utilizing wireless communication, smart appliances, and a meticulous item organization system. Moreover, it implements simulated Earth lighting and manages crew circadian rhythms effectively, crucial in space with its frequent sunrises and sunsets. Although the ISS offers extensive space for experiments and research, the Tiangong station's compactness and cutting-edge technology might provide a more streamlined and efficient operational environment for astronauts. And that's a wrap. So what do you think? Share your thoughts in the comments below. And don't forget to like and subscribe to our channel for more.